Good morning friends. Today we are going to see the unit 3, that is in unit 3 heading is Kinematics of Cam Mechanisms. First you have to know what is the meaning of cam, then we have to proceed further how to draw the cam profile, how to form the cam and follower profile. First you know the meaning of cam. What is the meaning of cam? Coming to unit 3 Kinematics of Cam Mechanism. The cam and follower terms, the two terms are very, very important. The first one is cam and the second term is follower. What is the meaning of a cam? The cam is a rotating element by means of any rotating device. We can use shaft for rotating or any other device for rotating the cam device or cam object. Therefore, cam is a rotating element or it is made to rotate in clockwise or anti-clockwise by using any devices. Therefore, cam is our rotating element. It is in different shapes. It does not have a circular shape, it has a different shapes. We will see the different categories of cam in the further continuation of the unit. Therefore, the cam is a rotating element which gives some motion to the other element. What is the meaning of other element? The next second element is our follower. The first element is the cam, the second element is our follower. The follower has it has a motion, it has a translation or oscillating motion or in a circular motion according to the motion of the cam. It follows the follower follows the cam profile. The follower has a reciprocating motion or oscillating motion or rotary motion according to the cam. Therefore, it follows the cam. Therefore, the name is given as follower. This is the meaning of cam and follower. Once again I repeat, the cam is the rotating element which gives the rotary motion to the other element or any motion to the other element. The follower is follows the cam profile, therefore it has some reciprocating or oscillating nature. Where it is used? Where this cam and follower is used? Mostly the cam and follower is used in the internal combustion engine, IC engines. Where it is used in IC engines? It is used in the valves. For opening of inlet and exhaust valve, mostly this type of cam and follower is used. And other devices, automatic devices, this type of cam and follower mechanism is used. Automatic machines. Then paper cutting machines, where we need the motion of the cutter. Paper cutting machines, we are using cam and followers. And mainly textile industries. In weaving and doubling, that is in weaving we need this cam mechanism, cam operating mechanism, cam and follower operating mechanism. Textile industries, and there are n number of applications are available. These are some applications, and also in lathe also. In lathe, we are using this cam and follower mechanism. In the lathe axle, we are using this cam and follower mechanism. These are the main forms or applications of cam and follower. We will see that some types of cam and follower. We will see some types of cam and follower. First, according to the types of followers. What are the types of followers? It is classified according to the surface of contact. According to surface of contact, there are different classifications of follower. The first is knife edge follower. According to the surface contact, we have different classification. Knife edge follower. Second one, roller follower. The third one, flat faced follower. Or it is also called as mushroom follower. mushroom follower. Mushroom follower. Then fourth one is spherical follower. According to the shape of the contact, according to the shape of the follower, surface of contact with the follower cam, we can classify the follower as knife edge follower, roller follower, flat face or mushroom follower, spherical follower. These are the some types of follower according to the surface of contact and the edges of the follower. First one is a knife edge follower. What is the meaning of a knife edge follower? The edge of the follower has a knife shape. You can see the edge of the follower as a knife shape. Okay, it is our normal cam diagram, cam follower diagram. It is a shaft, rotating shaft. It is our cam as a different shape, and it is our follower. In this type, due to the rotation, the shaft rotates, therefore the cam also rotates. Therefore, when the cam rotates, due to the nature of this cam profile, the follower has a translation motion. The follower will have a translation motion, that is, movement of follower will be in upward direction, upward and downward direction. It laterally translates upward and downward due to the follower shape. Due to the cam shape, the follower moves up and down. It follows the profile. Follows the path of the cam profile. It is called as a cam follower. Here, knife edge follower, the edge of the follower will be in the knife form. Therefore, it is a name given as knife edge follower. Knife edge. Coming to knife edge follower, due to the contact, minimum contact, there will be more wear in this knife edge follower. Therefore, it is not mostly used in different applications. It is an older one compared to the other. It is an older one. It is mostly not used in the icing engine due to the more wear and tear. Next, coming to the roller follower. The roller follower has a shape of a roller. The edge of the follower will be in the form of roller. The edge of the follower will have a roller. What are the advantages of this follower? Since there is another point we have to say, that is, it forms a higher pair. When you go for, we have seen in first unit, what is the meaning of a kinematic pair? In kinematic pair, there are two types of, that is, contacts or pairs. That is a higher pair and lower pair. Lower pair and higher pair. What is the meaning of lower pair? Lower pair is nothing but the surface contact. What is the meaning of higher pair? Higher pair is the point or line contact. Therefore, the cam follower has that is a point contact or line contact. It forms the higher pair. Therefore, the important point is cam mechanisms have higher pair. So, coming to follower, roller follower, the roller follower has a higher contact pair with the cam. It also follows that is the roller follower also follows the path of the cam profile. What is the advantage of this roller follower? It has some advantages compared to knife edge. The knife edge has more wear and tear, but roller follower, since the point contact has a wear and tear is very less compared to the knife edge follower. And also the roller follower has some advantage. It has a less thrust compared to the knife edge follower. And the sides of the cam, it has a very less thrust. And also we can use this roller follower in IC engines. In all the automobiles, this type of roller follower is mostly used. It is roller follower. Next, coming to third one, flat face follower. the edge of the follower will be in the form of a flat faced. The edge of the follower will be flat faced one. It is called as a flat faced follower. What is the advantage of the flat faced follower? Since there is a flat, there will be more contact area, therefore the wear and tear is very less compared to the knife edge and roller follower, and also the thrust will be very less compared to the knife edge and roller follower. And this type of follower is mostly used in all the automobiles, all the engine mechanism, and nowadays we are using only this flat faced followers compared to that. And also to reduce the wear and tear. Once again, we can reduce the wear and tear by having an offset of this axis. We can have some offset of this axis with the follower. Therefore, we can reduce more wear and tear in flat faced follower also. Next, coming to another main is for flat face is mushroom placed follower. The mushroom is nothing but the flat face is changed or to machined into a circular shape. When we are machined into circular shape, the flat face follower changes to mushroom shaped follower. Is another name given to the mushroom shaped follower. Next, fourth one is spherical follower. What is the meaning of spherical follower? The edge of the follower will have a spherical shape. Once again, we are changing this flat into a spherical one. Therefore, the edge of the edge face of this follower will have a spherical shape. To reduce the wear and tear. Once again, to reduce the wear and tear, we are going for a spherical shaped follower. It is called as a spherical shape. Once again touches it follows the path of the cam. It is called as a spherical. The spherical follower has more advantage compared to all the three. Since the area of contact is very less and less wear and tear is possible, and also the thrust, mainly you have to focus on the thrust on the cam. It also will have very less thrust compared to all the followers. These are some types of according to the surface of contact, surface of the edges of the follower. Then second category, according to the path of the follower, or according to the motion of the follower. First we will see the motion. According to the motion of the follower, according to the motion of the follower, it is classified into two types. That is translatory or rotary follower. Translatory or radial follower.
Reciprocating.
Translate or reciprocating. Translate or reciprocating follower. Then second category, oscillating follower. Oscillating or rotary follower. According to the motion of the follower, the translating follower, reciprocating follower, or oscillating follower, or rotary follower, you can call it as a rotary follower. What is the meaning of translating follower? The translation follower is nothing but it will move up and down. Just it will move up and down in a translation manner. In oscillating follower, most of the cases in flat face and spherical follower will have some oscillating nature of the follower. You can see the diagram, the same diagram. The follower has some oscillating nature in spherical follower. The same profile, but the follower will be in oscillating nature. When it touches with there will be an oscillatory motion. of this follower. It is our follower. It is our spherical follower. We are having some oscillating nature in this follower. The translation follower to all the follower, basic follower, right edge follower, roller follower, flat faced follower, and spherical follower will all have some lateral direction only, moving lateral direction, that is translation motion only, move up and down. But in oscillating or rotary follower, the follower will have some oscillating nature and the shape of the follower is changed accordingly. Next, according to the path of the motion of the follower. Same one, then according to the path of the motion. According to the path of motion of the follower, we can classify according to the path. Radial follower, then offset follower. What is the meaning of radial follower? All the followers, that is the axis of the follower and the axis of the cam will have in line with each other. That when you take the follower axis and the axis of the follower, that is cam also will be in line, or you can say it as a perpendicular to each other. That is the cam axis and the follower axis will be perpendicular to each other. It is called as a radial follower, and also in line with the cam axis. The follower axis are in line with the cam axis. It is called as a radial follower. Then offset follower, there will be some offset distance. We can see the roller follower, mostly the roller and flat faced follower have some difference in the axis. We have to draw the follower with some offset. This is the offset distance. Offset distance. To reduce the wear and tear and to reduce the side thrust on the cam, we go for an offset distance, offset follower. In offset follower, there will be some offset distance. You have to draw the follower with some offset distance. Therefore, for our application purpose, we are going to design the offset follower with some offset distance from the cam axis. It is called as an offset follower. These are some classifications of follower, and also there are some classifications of cams also there is possible. The main there are different types of cams. We are going to see only the main types. Radial or disc cam. Then second one, oscillatory or rotary cam or cylindrical cam. You can call it as a cylindrical cam. What is the meaning of a radial or disc cam? That is, you can see here the same picture, the flat faced follower here. The axis of the follower and the cam axis will be perpendicular to each other. Lie perpendicular to each other, and the follower has some translation motion. It is called as a radial or disc cam. This type of cams, all these types of cams are comes under the radial or disc cam. What is the cylindrical cam? It will be perpendicular. The follower and motion of the follower and the cam will be perpendicular to each other. But in cylindrical cam, it will be parallel to each other. The follower motion with the cam axis will be parallel to each other. We can see a cylindrical cam here. It follows the path. It follows the path of the cylindrical. It is our shaft, for example, you take. The cylindrical cam follows this path. It is our follower. It is our cam. Therefore, the cam has a cylindrical nature. The follower has a longitudinal motion. The follower will move this direction. It follows the path of this cam profile. Therefore, the cylindrical nature cam profile Therefore, the follower is the axis is in line with the cam axis. It is called as a cylindrical cam. And also in cylindrical cam there is an oscillating follower also. There will be some oscillating nature also. We can see the same follower with some oscillating nature. We can have some oscillating follower in this diagram. It follows, it oscillates. The follower oscillates. It is called as an oscillating follower. It follows the path of the cylindrical cam with an oscillating net. These are the another type of cams with an oscillating net. These are the types of cam. That is radial or disc cam and cylindrical cam. These are some types of all the follower and cams. Next, we are going to see the important terms used in the cam profile. What is before going to design the cam, you are going to see the important points of the terms used in cam profile.